Today, I will talk about LiDAR sensors for the enhanced safety. Carnavicom is located at Sung-Joo City in Korea and manufactures automotive goods such as dashcams and electronic toll collection systems and navigations. And we are developing LiDAR sensors and communication V2X for autonomous driving. And we are also developing safety devices for marine mobility. There are three key factors for to implement autonomous driving. First is perception with sensors and decision by AI and driving control. For perceptions, there are key sensors like camera, radar, and LiDAR. Camera and radar has been used for ADAS systems in a long time. However, autonomous driving is implemented with LiDAR sensors, just like DARPA Grand Challenge in 2005. This is a Uber crash accident in 2018. A pedestrian was hit by a self-driving car by Uber. And this is an article from Reuters. It says the Uber self-driving vehicle reduced their safety sensors. As you can see, they reduced the number of LiDAR sensors from 7 to 1, whereas they increased the number of radar sensors from 7 to 10. But it is said that there was a software flaw. Why did the software cannot the software detect the pedestrian? There are many global LiDAR players at present. Velodyne, Luminar, Quanergy, Valeo, and so on. The shapes and technology and size are very different one from another. There are few LiDAR sensors in commercial vehicles. You see, here is a laser scanner from Valeo, which is installed in Audi A8. And what is LiDAR? Why is the LiDAR so important for autonomous driving? LiDAR stands for light detection and ranging. LiDAR uses photon lights in infrared spectrum, which has a longer wavelength than 700 nanometers. It detects photon by photoelectric effect in photo detectors to measure the range to an object with the speed of light. What is the LiDAR signal? The laser pulse propagates in the atmosphere, and it scatters by an object. And in a portion, the scattered light returns back. The laser beam, when the laser beam penetrates the atmosphere, it attenuates, and when it comes back, it attenuates one more time. The T is a transmittance, and the physical process can be expressed in a mathematical form, which is called LiDAR equation. The LiDAR equation looks complicated, but the physical meaning is very clear. P0 is the laser pulse power, and K is the system constant, and beta is the albedo of an object. And the signal is inversely proportional to distance squared. This term is transmittance. As you can see, it's exponential. So when the weather is very good, we can neglect this term. But when the weather is poor, like fogs and heavy rains, this term become dominate. And the LiDAR signal had some noise. There are three big factors of LiDAR sensors. The first one is three-dimensional beam scanning technology. Second is distance measurement. And third, the laser wavelength and power. The upper part is more engineering challenges, and the lower part is more physical, I could say more fundamental. The 3D beam scanning technology, there are many types for that. Spinning LiDARs, mechanical steering LiDARs, MEMS, mirror scanning LiDARs, optical phased array, and flash LiDARs. But the technology can be categorized in scanning and focal plane array. Scanning means directing laser beam to individual position step by step. And focal plane array, FPA, it illuminates the frame at once, just like camera flashes. And it can be sub-categorized mechanical scanning, and these are the non-mechanical scanning, which means this technology don't have moving parts, mechanically moving parts. We call it a solid type. Carnavicom has mechanical scanning type LiDAR sensors, and we are developing the solid type LiDAR sensors using MEMS technologies. The distance measuring, for distance measurement, there are several technologies. Time of flight, FMCW, AMCW, trigonometry, and phase. Phase, this is widely used for TOF cameras. It can also categorized in direct detection and indirect detection. Direct detection is time of flight, which is mainstream in LiDAR sensors. And Carnavicom also use the TOF technology just as global LiDAR players. And we are planning to develop the FMCW technology too. And laser wavelength and power. The spectrum range of lasers in LiDAR sensors is a near-infrared. There are 850 nanometer, 905, and 1.5 microns. And there are several laser types, such as laser diodes, VCSEL, diode pumped solid-state lasers, and MOPA fiber lasers. Nowadays, most of LiDAR sensors use low-power laser diodes like LD and VCSELs. But in order to increase the range, we need high-power lasers. But for that purpose, the eye safety is very important. So there are two types for eye safety, which has the wavelength of 1.5 microns, the diode pumped solid-state lasers and MOPA fiber lasers. Carnavicom is using laser diodes of 905 nanometer, and we are developing eye-safe lasers, MOPA fiber lasers. 1.5 eye safety wavelength has very big advantages. In this graph, you can see 1.5, the green line. At 1.5 wavelength, the solar irradiance is 3 times lower than at 905 nanometer. It means the background from the sun lower 3 times at 1.5 micron wavelength. And this is maximum permissible exposure. X-axis is wavelength and y-axis is MPE in logarithmic scale. You see at 905 nanometer, the yellow line, it's about 10 to the minus 6. And at 1.5 micron, it's up to 1. So there are about 1 million times difference. It means 1.5 micron wavelength is much, much safer than at 905 nanometers. And light is an electromagnetic wave. Every electromagnetic wave diffracts and has beam divergence. And the beam divergence depends on the wavelength. I would like to compare the wavelength of a laser diode and 77 gigahertz millimeter wave radars. The difference about 4,000 times. It means with LiDARs, it's very hard to get good resolution just as LiDAR sensors. It looks like with LiDARs, radar sensors make sensing with the stick, but with LiDAR sensors, it just like with eyes. So we can get very high resolution 3D images. Carnavicom has several types of LiDAR sensors at this moment for industrial and automotive applications. And Carnavicom LiDARs installed for safety sensors for monitoring on pedestrians waiting for traffic signals on crossway, and for the platform screen doors of city subway. I can play the movie clip. Let's return back at the slide. This shows this slide shows the data from our two-channel LiDAR sensors. Unfortunately, I can play the movie clip, but it detects cars very well, even though these LiDAR sensors are developed for industrial purpose. And this is also movie clip. This is our 17-channel LiDAR sensors. As you can see, with these LiDAR sensors, we can see the contour of people very well. And we are developing new type of laser sources for eye-safe, high-power MOPA fiber lasers. This is the configuration of the fiber lasers. It is very important for future applications and future technologies. In conclusion, it is appropriate time for Carnavicom to enter the market for industrial and safety markets. And we are developing MEMS technology for next generation. And we have occupied MOPA fiber laser technologies for long-range TOF and FMCW LiDARs. And we are trying to make a sensor fusion with LiDAR, radar, and camera sensors. And we are trying to merge them with V2X communications. Thank you.